Okay, so we looked at the first of several equations, the Rydberg equation, and I hope you copied that down on the front with all your equations because there's quite a few in this chapter. The next equation that we're going to introduce is the Bohr equation. And this is from Niels Bohr. He developed this idea when he was studying the movement of electrons, and he said that the energy of an electron, E, is equal to negative B over n squared. And this represents the energy of an electron as it is sitting in a particular orbital. And when you look at this, it might seem a little odd at first that there's that negative sign in there, but the negative sign for the energy just means that it's at the ground state. So don't get all worked up about that. B is the Bohr constant, 2.18 times 10 to the negative 18th joules. So you see it has units for energy in joules, and n is the principal quantum number, the main energy level, so it has no units, so your energy ends up in joules. So what is the energy of an electron in the second Bohr orbital? 2, or second, is an integer, so it is a counting number, so it has no significant figures and it doesn't contribute to sig figs here. So we know E is equal to minus B over n squared, and that's equal to negative 2.18 times 10 to the negative 18th joules divided by 2 squared. So negative 2.18 times 10 to the negative 18th joules divided by 4 gives me negative 5.45 times 10 to the negative 19th joules. Now again, when you look at this, you ask yourself, does that seem like a reasonable answer? And it does, because it's a small amount of energy, and it's the energy of one electron just kind of hanging out in an orbital. And again, this negative sign in there just means that it's a low energy sitting in its lowest basic energy state. So the sig figs are determined by the 3 sig figs in the Bohr constant. Okay, go ahead and do the next one on your whiteboards with your groups.